Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Given an array of integers R, we want to find out the inversion count in the array. Okay, two elements, R of I and R of J form an inversion if R of I is greater than R of J and I is less than J. Okay, so let's see through an example what the problem is trying to say. So here's an example R, right? So, so what is an inversion count first of all? So for example, right? So this five, there's this element five, and then there's this element three, right? So 5 is greater than 3. 5 is greater than 3, right? So this is one of the inversion count. Okay. Same can be, we can consider 5 and 2 as well. It should be in sequence basically. So 5 is greater than 2. So there's another inversion count. Okay. There's another inversion count, right? Similarly, 5 is greater than 4. There's another inversion count. There's 5 is greater than 1. There's another inversion count. So inversion count is nothing but an element is greater than the elements coming after that particular element. Okay, coming after that particular element, and it need not be contiguous. For example, 5 and 3. So it can be 5 and 2 as well. We have to consider, right? They are in sequence. They should be in sequence, not necessarily contiguous. Okay, so this is an inversion count. Let's quickly calculate like what is an inversion count? What are the number of like what is the inversion count for this in this particular example, right? So 5 is greater than 3, right? There's one inversion count, then 5 is greater than 2. There's another inversion count, 5 is greater than 4. There's another inversion count, 5 is greater than 1. There's another inversion count. Then let's calculate for 3. 3 is greater than 2. There's one inversion count. 3 is greater than 1. There's another inversion count, right? Then, for example, let's calculate for 2. 2, there's inversion count. There's inversion count for this particular one, right? And then we have 4. 4 has inversion count of 1 again. So if you see, what is the inversion count here? 4 plus 4. So total count is 8. Total inversion count is 8. Okay. So this is the ask. I hope you have got the problem. Now, let's see the intuition behind solve the problem. Okay. So let's first see the naive approach quickly. So here what we can do is we can have two for loops. Okay. For I equal to 0 to n, right? And another for loop can be for j equal to I plus 1 to n. Okay. This will give you all the combinations. For example, if I is here, 5, right? 5 is here. So j is starting from here, right? J is starting from this particular, the next element of I, right? For example, this loop will run for these elements, right? And then we can compare the element at 5 with all the elements at j positions, right? And then we can have our count variable here, right? We can have a count variable here. And for example, if the element at I position is greater than element at j position, then we'll increment our inversion count. So in this way, we'll calculate our inversion count. Okay. But now what will be the time complexity here? It is going to be O of n square. Okay. It is going to be O of n square. So can we do better than this, right? Can we have a better time complexity than this particular time complexity? Okay. So let's quickly see what can be the solution. Okay. So here we can use merge sort in order to solve this problem. So let's see how. Okay, let's see how. So you know how merge sort works, right? So we divide the array, we keep on dividing the array. For example, L is here, right? And H is here. Okay, L is here and H is here. So we calculate the mid, right? So what is the mid? Mid equal to L plus H by 2, right? Mid is equal to L plus, so 0, 0 plus 4 by 2. H is what? 4 by 2. So mid is what? 2, right? Mid is 2. So what we do? We divide the array, right? We divide the array into two parts. One is L to mid, which is 5, 3, 2. We got, right? And another is mid plus 1 to high. Mid plus 1 to high. Mid is what? Mid is here, right? So mid plus 1 to high, 4, comma 1. Then we keep on dividing the array, right? We keep on dividing the array. For this particular thing is mid is 1. So what will be the division now? 5, comma 3 and then 2, right? We keep on dividing the array till we have one element in each array, in each sub array we can say, right? So here, for example, 5 and 3. Okay, so we have divided the array. So we have each single elements here. Okay, now once we have done the division, then we do the merge process. Okay, so now we are going to check here. So we have two elements here. So now if you can see, right? So 5 is greater than 3, right? So what we are going to do? We are going to sort, right? We are going to sort basically. When we are going to return, it is going to be what? 3 and 5. We are going to sort, right? We compare the elements, right? It is going to be 3 and 5. But now with this sorting, we also have to take care of calculating the inversion count. So 5 is greater than 3. So we have got one inversion count. So let's have one variable here, one inversion count, right? One inversion count. Okay. Now we have this state, 3 and 5. Okay. So we are done here. We have done here. Right now we have this state 3 and 5, and we are going to compare 2. Now what we are going to do? We are going to compare 3 and 2. Okay. Now 3 is greater than 2. So we need sorting over here. Along with that, now let's see what is the state here. Let's see what is the state here, right? The state here is 3 and 5 and 2, right? And 2. And what is this? This is L. This is mid, right? This is mid. And this is what? This is H, we can say. Okay. Or this is right, we can say, right? Right. So now what are we going to check here? We're going to check this in this element, right? So 3 is greater than 2. So I think we have found the inversion count, right? We have found the inversion count condition now. So 3 is greater than 2. So definitely there's this, we have got an inversion count. But since now 3 is greater than 2, so that means the elements coming after 3, those will also be greater than 2, right? Those will also be greater than 2. 5 will also be greater than 2. So we have basically 2 inversion count here, right? But now what will be the formula? So here, for example, the first element itself is greater than 2. So the formula will be inversion count, inversion count plus equal to mid minus I, or mid minus L, we can say mid minus L plus 1. This will be the formula for this particular case, right? 3 is greater than 2. So what is mid? Mid is, let's say, mid is what? Mid is 1, right? Mid is 1. 1 minus L is 0 plus 1, right? Which gives us what? 2, which gives us 2. Inversion count is 2. Yes, right? Inversion count is 2. 3 and 5. They are 2 inversion count. They are both greater than 2. Okay. So we are going to increment 1 plus 2, right? To the inversion count. 1 plus 2, right? So now we go, now it will be sorted 2, 3, and 5, right? 2, 3, and 5. This is sorted, but also we have calculated the inversion count along with that. Okay. Okay. Now this particular case, we can see, yes, 4 is greater than 1. So here definitely 4 is greater than 1. That means we have found an inversion count condition. So we're going to increment 1, and also we're going to sort. So sort the array. Okay, right? 1 and 4. Okay, 1 and 4. Now coming to this particular case, right? We have 2, 5. Let's write here. We have 2, 5, and we have 1, 4. Right? Now if we compare again, right? If we compare again, 2 is greater than 1. So we have found the inversion count condition again, right? So since 2 is greater than 1, then the elements coming after 2 will also be greater than 1, right? Will also be greater than 1. That means this formula invokes again. So what is mid is here? L is here, right? So mid is what? Mid is 1. So according to the formula, mid minus L plus 1, right? So mid is 1 minus L is 0 plus 1, right? Which gives us 2. So we are going to increment the inversion count with 2, basically, right? Because these two elements both are greater than 1, right? Again, right? Again, we go to this particular element, 5, right? Now 5 is greater than 4. 5 is greater than 4. So we have one more inversion count, right? One more inversion count, which will be 1. So now we send what? Now this was it, right? This is it, 2, 5, 1, 4. So we now also sort the array, right? We also now sort the array. So it will be 1, 2, 4, and 5. Okay. 1, 2, 4, and 5. So we have sorted the array, and we also have our inversion count, which is what? 4 plus 3, 7. Somewhere we might made a mistake here. Let me check. So 5 is greater than 1 and 4. Okay, yeah. Yes. So this, for example, for this condition, right? For this condition. Okay, let me quickly. So what was it, right? What we checked, 2, 5 and 1, 4, right? 1, 4. So when it was 2, it was greater than 1, right? Similarly, 5 was also greater than 1. According to a formula, we had added, right? According to this particular formula, it was 2 here, right? It was 2. Okay. Now we coming to 5. 5 is also greater than 1 and 4, right? 5 is also greater than 1 and 4, right? So that means we have additional not 1 but 2, basically 2, because 5 is also greater than 1 and 5 is also greater than 4. That is why the inversion count is what? 4 plus 3, 4 plus 4, basically, right? Which is 8. My bad, which is 8. So the final count is 8. So I hope you're getting the intuition, right? Now I think let's go to the code. You'll understand better. So before going to the code also, if you see what will be the time complexity here, it is going to be, what is the time complexity of merge sort, right? It is O of n log n. Okay, O of n log n. and space complexity, it is O of n, right? It is O of n. So this is a better approach because it is taking lesser time complexity than the previous one, right? Which took O of n square. Okay, so let's go to the code. I think you'll understand better. Before going to the code, I'll request you to subscribe to the channel, like the video. Okay, let's quickly reset this code. Okay, and let's implement. So now, as I told, right, we are going to do what? Merge sort. So let's write the code first. I'll also explain, like I'll also dry run with an example. Okay, so let's, so first I'll show the Java code followed by C++. Okay, so let's write merge sort, array, 0. What it is, L equal to 0, L equal to 0, and H equal to, let's say, air dot length minus 1, right? So L comma H will say. Okay. Now let's write, now let's implement merge sort. Static void merge sort will say, static void merge sort, and it is going to be what? Int array int L int H, right? Now what we are going to do here is, we want to divide, right? Divide the array. We want to calculate, for example, int mid equal to L plus H, L plus H by 2, we'll say, right? By 2, and then we'll call merge sort again. Again on what? For example, array L will be as is and mid, right? Mid. Similarly, for the second part also we want to divide, all right? We want to divide, right? Mid plus 1 and H it is going to be. So if you see, right? If you see, for example, let me uh let me delete this. Okay. Here. Let me re-explain this. Okay. So what we're doing here is, okay. Yes. So let's see. So this is our array, right? 5, 3, 2, 4, 1. Okay. So what we do? So we have calculated mid. What is mid? L plus 0 and 4, right? Mid equal to 0 plus 4 by 2, which is nothing but mid is 2. Now what we do? We divide the array, right? We call recursively the merge sort. We call recursively. So how we are calling here? So 5 comma 3 comma 2. So L merge sort L to mid, basically mid, right? What we are doing here is we are passing L to mid, right? Which is nothing but we are dividing the array till here, right? The first part is here, mid, right? Mid is pointing at element 2. Similarly, mid plus 1 we are saying 4 comma 1. The second merge sort we are calling for mid plus 1 to H. Okay, so this is the second part, and this is the first part. So I hope you're getting that, and we are going to call this until we should have a base condition. If L is greater than equal to H, right, is greater than, then return. This is a base condition, right? It shouldn't happen that low should be greater than equal to H, right? If it is the case, then we have to return from there. So we have calculated we have called the merge sorts. Now, after this, right? After this, we want to call merge. So when this will be called, let's write air L comma mid comma H, we'll say. So when this gets called merge, when we have all the single elements, right? 5, after dividing, right? 5, 3, 2, 4, and 1, right? And 1. So we are going to, from the bottom, we'll keep on merging, and we'll keep on calculating our inversion count. So this is, now comes this merge function, right? When we have single elements, now comes now the merge function is called, and we're going to calculate, we'll implement that merge function. Let's implement that. Static void merge, right? And what are the parameters? Int air, int L, int mid, int H, we can say, right? Now what we're going to do is, we'll have 3 variables. I equal to will be starting from L. It's a standard merge function, right? J equal to mid plus 1, which is the second part, right? Which is the second part. And K equal to, it will start from L. Now what are we going to do? We also want a temporary array, right? O of n, temporary array. Temp equal to new temp, which is nothing but air dot length of size of same, right? And we'll pass our temp here, temp. And also let's have another inversion count variable, right? We're going to calculate the inversion count. It will be of size 1 only. We'll pass it here. Okay, inversion count. Let's pass it here. Int temp int inversion count, right? And then we want to pass it here as well. Temp and inversion count. Temp and inversion count. Okay. So it's of size 1. It's of this inversion count is of size 1 because it will hold only the inversion count number. Okay. 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 So let's add here as well. How it was. Sorry. Int temp and int inversion. It's also an array size 1 inversion count. Right. Now, okay. Just got a call. Yeah. Now we have this. Now what are we going to do? We're going to write while I is less than the standard merge function, right? I'll explain through the example. I is less than mid and then j is less than equal to h basically. J is less than equal to h. Okay. Now what we're doing here is it's like this. It's like this particular, for example, right? For example, we had this what? Uh, for example, we had this, let's say we have two sub arrays, right? 2, 3, 5 and 1, 4, right? And 1, 4. Now J is pointing here. J is pointing here and I is pointing here, right? I is pointing here. So we have H over here, which is pointing here. We have mid, which is pointing here. So we're comparing I and J. We are comparing the two arrays, right? The two sub arrays, and we want to merge, right? We want to merge and we want to sort basically. We want to have the merged sorted array. So I and J we are comparing, right? I and J we are comparing. So what you're doing here is if array of I, sorry, bad. If array of I is less than equal to array of J, then simply temp of k. K is what? K is a index for this temporary. So wherein we are having the sorted elements, right? Temp of k and array of I plus plus, right? Array of I plus plus we are doing. We want to increment, right? Else if this is a case, for example, if this is a case, if this is a case, right? For example, we have 5 here and 2 comma 3 here, right? Or let's have better 3 comma 5 here and 2 here. This is one sub array, this is another one, right? So we are comparing. So 3 is greater than 2, right? 3 is greater than, so we have found an inversion count. So this is the case, right? Array of I is greater than array of j. So here what we're going to do, in count of 0 plus equal to, I have already explained this, mid minus I plus 1, right? Why? Because if you see, right, for example, this is the mid, right? This is the mid, this is I, and this is J, right? So R of I is greater than R of J. So since this element is greater than 2, so it's obvious that the next elements, all the elements after 3 are also be greater than 2. So we have to take into account these numbers also for inversion count. So what is the formula? Mid minus I. What is mid? Mid is 1. I is 0. So mid minus I. Mid is 1. I is 0 plus 1, right? Which will give us 2, right? So these two elements are greater than this one. So that is why inversion count is 2. So here it is a formula mid minus I plus 1. Okay. So then now we'll have a standard merge. For example, if one of the sub arrays got exhausted, right? So let's calculate. For example, I is still less than equal to mid, right? So we're going to have those. So temp, let's copy rather than, yeah. So here is a case and we'll have another one. While j is less than equal to h, right? Equal to h, then we want to have, oh, we also want to copy, right? This particular thing. Only we want to sort this also, right? Temp of k plus plus and array of j plus plus, right? For example, what we are saying here is, for example, what we are saying here is, if this is a case 3 comma 5 and here is 2, right? And we have a temp array here. So what we are doing here is, now I is pointing here and j is pointing here. So we calculate the inversion count. Now we want to sort, right? So what we are doing is, we are writing k is here. We are writing array of j here, right? 2. That's what we are doing here. That's what we are doing here, right? Temp of k, array of j plus plus. Okay. So here, this is it. Let's copy this as well. So once we have the sorted array, right? Once you have sorted array, once you have some sorted part, then we have to rewrite into the original array. Z, H plus plus Z, right? Let's write it back to the original array. Z equal to temp of Z, we'll say, right? Temp of Z. This is it. This is the code. And finally, what we want to do here is we want to return the inversion count of 0, right? So let me compile this. Okay, it's compiled successfully. Let me submit. Thanks for watching. I hope you have got the solution. Please don't forget to subscribe to the channel, like the video. Okay, let's quickly see the C++ code as well. I'll attach the code to the GitHub and share the link. So here it is, right? Not much difference. Here we are having temporary array. We are calling merge sort here. Merge sort I've already like here calculated the mid, and then here separately we are having inversion count. We haven't passed that array. Okay, so merge sort we are calling again and again, right? Until we have single elements, and then we are calling merge there. Okay, we are calling merge there. So now I've explained this, right? Now we are comparing the two sub arrays, right? We are comparing the two sub arrays and we are sorting accordingly. If the array of I, if it is greater than array of j, then we are calculating the inversion count here. Finally, this I have also explained. And once it is done, we are returning the inversion count. This is a local variable here. And then we are collecting to the global variable, you can say, which is local to merge sort. Okay. And then finally, we are returning our inversion count. Okay, I'll attach the code in the comment section. I hope you have got the solution. Thanks for watching. Don't forget to subscribe to the channel, like the video. Have a happy, healthy, wealthy, and a great day. Thank you so much.